Welcome once again to this wonderful channel. It's your beautiful and favorite tutor once again. That's Phillips Olamide Oladele, philosopher. And I'm going to be taking you again into another world in chemistry. And this is an advancement of our study on transition methods. Transition methods are so useful and they are involved in forming some group of compounds that we call coordination compound. Coordination compounds are overall neutral species that are made up of two ions, the counter ion and the complex ion. The complex ion is made up of two things, which is the ligands and the central melter. And this particular video is just to solve some questions on this topic. It's not the very or the basics knowledge. You can check my channel and look for the basic knowledge of coordination compound. This one is for students that have the prerequisite knowledge already, but they just have the difficulty in naming coordination compound, interpreting structure into name and name into structure. In this video, I, Phillips Oladele, philosopher of you graduates, I'm going to make it simple for you. Just keep watching. But if you have not subscribed, why are you watching my video without subscribing? It is a sin. Please, subscribe. Thank you. Okay, let's start with this. The first question said, predict the chemical formula of the following compound. And as you can see, compound A is sodium tetrachlorozincate 2. Compound B is triethylene diamine chromium 3 chloride. Now, compound C, and so on and so forth. So let me say something very quickly. In the naming of coordination compound, you will see that there are some group of name they will write together. There's some group of name they will write together. Anyone that you notice that there's no space between the letters, they are all in one category. So you have to identify the categories. A coordination compound is made up of two things. So in this case now, I have sodium that was spaced from these other guys. So sodium, since it's the one standing alone there, it's not complex. Is that complex? It's not complex. So it's going to be a counter ion. So sodium here is serving as the counter, countering this whole complex. Because a complex is something that contains more than one species. And don't forget that a complex ion must contain a ligand and a central metal. This is tetrachloro. This tetra is just a prefix. So the main ligand here is chloro. Ligands are either negative or neutral species. And we all know that chloro is chlorine, and chlorine is a non-metal. It's electronegative. So that's our ligand. And zincate is our transition metal. Don't forget, though it was later taken, it has later been proven that zinc and scandium is no longer a transition metal, but they were once a transition metal. That is why we cannot just help but talk about them. So zincate is representing transition metal here, and this number is the oxidation state. Same goes for all of these from A to D. So always know that anyone that they are not spaced and they are much, they are the complex ion. And the one that stands alone, that stands in gap, is a counter. Your enemy will never come around you when you are doing something good. They will stand afar. That's it. So a counter ion is going to be standing at a gap. You get it? It's going to be standing at a gap. Okay. Now let's answer this. But before we proceed, I would like you to know something. And before we do that, let's start with number one. So if I want to write the chemical compound formula for A, sodium tetrachlorozincate 2, I'm going to start by, you are going to, this curly brace is always used to enclose our complex ion. So when you open this curly brace, you will target these people that are complex, that are much, that they are not just single person, like this. I started writing them down. So the first person you are expected to write inside this curly brace is the metal, the transition metal involved. And the transition metal involved here is our zincate. So you are going to write zinc, yeah. Then you now check who is the ligand. The ligand there is chloro. Then you write chloro. But that prefix is telling you the magnitude of the chloro, which is what? 4. Tetra means 4. Then you write 4. Then I said 2. That 2, this number is the oxidation state of metal, OM. Oxidation state of metal. Please take note of this formula. This is my own formula. It was inspired. I derived it to make this subject easier for myself. You can also use it for yourself. Know this formula. I will come back to it later. Now, after I've written this, you don't need these two for now. Just write your zinc and your chloro and the magnitude of chloro. If it is penta, you'll have put 5 here. But in the question, they said tetra, so it is Cl4. Now, the counter ion, which is sodium, is now standing alone, and it comes first. So the way it comes first in the naming, it must come first in the write-up. That means the sodium will be in the front. But is this all? No, that's not all. You have to know what is the magnitude of this sodium. Is it only one that you need to counter this complex? Or is it 2 or 3 and so on? How will you know? A counter ion is functioning, countering the complex ion, the charges on the complex ion. So you have to know what charge is this place carrying. And you know that anything that this colibrace is a complex ion, and this guy alone is a counter ion. So before you can know how much of counter ion you need to counter this complex ion, you have to know what charge is this duplex carrying. And how do you calculate that? That's why you need this formula. This Cc means charges on complex ion. So charges on complex ion equals to oxidation state of metal plus ligand. So you have to get the oxidation state of metal. The oxidation state of metal must have been given to you in the name. That's what this 2 that I told you to neglect the other time is standing for. So this 2 is to the respect of this syncate. So that's the OM, oxidation state of metal. So that means what you have here is 2 plus. Don't forget that metals are electropositive. They are cations. That's why it's 2 plus. And since chlorine is a non-metal and it is actually carrying 4, then metals are negatively charged, and it's 4 here is going to be minus 4. That means the whole effect of what will be here on this duplex depend on the interaction between the members of the duplex. So when this is now the OM, your OM, and this is now your ligand, your L. So this is OM, this is L. And in this formula, I said this place is your Cc, this up. So you are finding your Cc. I want to know the charge on this duplex. So your Cc is what? OM plus ligand. So by the time you do that, that will be what? That will be 2 plus minus 4. That's going to be what? 2 minus 4, which goes what? Minus 2. That means the charges here is going to be 2 minus. So how many sodium do you need to counter a complex ion that is 2 minus? If you are a counter ion, you must counter exactly the number of charges that is on your complex ion. So if there is 2 minus on the complex ion, and I as sodium am positive. You know, positive is the opposite of negative. Only positive can counter negative, and only negative can counter positive. So sodium is positive, but sodium is a group 1. It only has plus 1. So 1 sodium is plus 1. And since this is 2 minus, that means I need 2 sodium. That means the actual and the correct formula that you're supposed to have is Na2, that is countering your 2 minus, which is on your complex ion, and this. But once you have put the required number of sodium that you required, this does not really need to show. So this is the correct representation of this compound. So this Na2 is there because definitely there is 2 minus here. So 2 sodium is actually serving as a counter for 2 minus, which is the Cc, charges on the complex ion. How do you get the charges on the complex ion? Oxidation state of metal, which is plus 2 here from our name, and because of the magnitude of 1 chloro is minus 1, and I have 4 here, that's going to be minus 4. So it was when I add 2 and minus 4 together, that's when I get these charges on complex ion. So once you get the charges on complex ion, you can now fall back here. Magnitude of counter ion equals to charges of complex ion. So if complex ion is 2 minus, that means the number of counter ion that you need will be 2 also, but it will be 2 positive. So once you put the correct number of counter ion, then you don't need to show any of this. So in normal chemistry, we expect you to leave your answer in this way. Hope you understand.